I'd like to show you how to sketch a graph of the form y is equal to the sine of x minus c, or y is equal to the cosine of x minus c. And I'll use the example y is equal to the sine of x plus pi over 3. We're going to determine the period, and then we're going to sketch the graph of the function. And if you remember, when we determine the period, this will tell us whether our function will have a horizontal compression or stretch from the function y is equal to sine of x. We know that the period of the sine of x is 2 pi. We also know that the way that you modify a period is to multiply your input by something. So if you notice in our example, x has a multiplier of 1. Its coefficient is 1, so that means there's going to be no effect on the period. So the period of the sine of x plus pi over 3 is 2 pi. So no horizontal compression or stretch going on here. We also need to recognize that when you add or subtract a constant to the input, this is going to cause a horizontal shift. So our whole curve is going to move from where it is to the left or to the right. So what we've determined is that there's no change in the period, and that yes, we do have some kind of a horizontal shift. So the graph of sine of x plus pi over 3 is going to look almost exactly like the graph of y is equal to sine of x, except for that we're going to shift that graph, y is equal to sine of x, to the left. In other words, a horizontal shift of negative pi over 3. So we shift it to the left by pi over 3 units. Now, how did we come up with negative? Well, compare the form. The form is sine of x minus c, and our example has x plus pi over 3. Well, how do you get a minus out of a plus? Well, if we write it like this, sine of x plus pi over 3 is the same thing as the sine of x minus a negative pi over 3, now you can more clearly see what that shift is. It is a negative pi over 3. So we have two ways that we can approach graphing this. One is the simplest, really, for this kind of a problem where you only have a horizontal shift. You could graph sine of x and then pull that curve in this place to the left. We would pull that curve by pi over 3 units to the left and plop it down there, and we'd have our new graph. The alternative method, and this is better when you have more complicated transformations. In this case, it would just be harder, but when you do have more complicated transformations, then you might want to use the quarter point method. So to use the quarter point method, I'll show you that first, and then we'll show you the easier method in this case. We're going to divide our period. So we're going to take the interval from 0 to 2 pi. So that's an interval which is 1 period in length, so 1 repeat of our pattern. We're going to divide that into 4 chunks. So if you take 2 pi and divide it by 4, you get a length of pi over 2. Let's place that on a number line, which you can imagine as the x-axis. Starting at the left with 0, we're going to add pi over 2, and that will take us to the end of our first chunk. Add another pi over 2, we're at the end of our second chunk, another pi over 2, and finally the last adding of pi over 2 gets us to the end of our interval. And over this interval, we'll see one complete repeat of the pattern. If we had to graph this over a longer interval, we would just simply repeat that pattern. Next, we need to find corresponding y values for each one of those x values. So we draw a table. We're going to plug in the values for x and solve for y. So let's start with plugging in x is equal to 0, so we get sine of 0 plus pi over 3 is equal to the sine of pi over 3, and you can just plug that into your calculator and you get about 0.87. Now you may recognize that pi over 3 is part of a special triangle, so you could figure out what the exact value is. But since we're graphing, we would really like an approximate number that we can actually place on our graph. So do the same thing for the rest of the points. Find an approximate y value. The next thing that you'll do is you'll construct your graph and you'll plot these 5 points and you'll connect the dots and you'll get your new graph. So let's take a look. If you look at the blue line, that is the graph of y is equal to sine of x. The black line is our new graph. So I can get that new graph by placing the points that I just calculated and then drawing the curve. Now here's the other method, and this is good for simple phase shifts like this, or if you have really great space visualization skills, you could probably handle a lot more complicated shifts. I happen to not have that great of space visualization skills, so I often find myself doing the quarter point method, but I think I could handle doing the more visual method for this particular one. So what is that method? Well, pick any point on your y is equal to sine of x, and it really doesn't matter where it is, but pretend like you're tying a rope around that point, and then you take your rope and you're going to yank that whole curve to the left, because remember that our phase shift is to the left by pi over 3 units. So just yank it to the left, figure out where that point would now end up, yank your whole curve that way, and you've got your curve. You've got your new graph. All right, so you've now seen 2 ways to graph a transformation which involves a horizontal shift, by the way, is also referred to as phase shifts.